All right, so we are going to simplify some polynomial expressions, and we're going to take a look at A first. Question A is asking us to simplify 2t plus 6 over 5t plus 15. So here's what we're going to do. If you identify as male, I would like you to please simplify the numerator. If you identify as female, please simplify the denominator. If I have not described you, then pick one of the two and factor it. I'm sorry, I should have said factor. We are factoring. So right now, everyone is factoring either the numerator or the denominator, but not both. You are only factoring. If you want to do both, you can do both. That's fine by me. All right, so about 5 more seconds, please. 5 more seconds. I probably should have paused the video because how fun is it watching or listening to people? All right, so here we go. Do I have a volunteer who factored the numerator to tell us what you got when you factored the numerator? All right, Axel?
So there's you can divide both by 2.
Okay.
Since 2 is a common, so you have 2 times t plus 3.
All right. Can I have someone who factored the denominator help us with this one? All right, Lainey?
Well, because 5 goes into 5 and 15, so it'd be 5 times t plus 3.
All right, so now we have successfully factored both the numerator and the denominator. Are there any common terms to the numerator and the denominator that we can divide out to equal 1? Clara?
T plus 3.
T plus 3 is common to both. So what is t plus 3 divided by t plus 3?
0.
It's not 0.
1.
It's 1. It's 1. And so we end up with 2 times 1, which is?
2.
5 times 1, which is?
5.
And therefore, we've simplified the polynomial expression. Not too bad. Now, I will say that this problem has a nice, clean, easy answer, 2/5. That feels good. However, it's going to be more common for you to have an answer that is a polynomial, that has a polynomial still in it. That's okay. All right. So let's try this one. Let's do it this way. If you are on the right side of the room from me, please factor the numerator. If you're on the left side of me, would you please factor the denominator? If you're directly in front of me, pick one of the two sides. I don't care. So you're factoring one or both. You can factor both, Eric. That's fine. So you're going to go ahead and do your factoring. I'm going to pause the video. All right, do I have a volunteer who can tell us what you got when you factored the numerator? All right, let's go, Abby.
2 times t plus 1.
All right, C or no? C. All right. Can I have a volunteer who factored the denominator? Kid.
T minus 1 times t plus 1.
T minus 1 times t plus 1. C or no? C. All right. Do we have a common term that we can divide out?
Yeah.
Okay. What is that common term?
T plus 1.
T plus 1.
T plus 1.
So we are going to say t plus. What is t plus 1 divided by t plus 1?
1.
Thank you for saying 1. All right. And so we are left with 2 over t minus 1. And that's it. And it's okay to have a t minus 1 in the answer. That is fine. We are only trying to simplify the expression. Now, it's not going to be uncommon, especially in physics, to have expressions that are polynomials with multiple variables. So simplifying something like that will or could end up with a polynomial still in the simplified version. That's okay. All right. All right, so the next one, a little bit trickier, but I think you're going to be all right. So we have 3x squared plus 5x minus 2 all over 6 plus x minus x squared. So, if you are in the first two table groups, so that's you four, all of you, would you please factor the numerator, the back two table groups, and it's the two old grumpy men and the Muppets. Would you please factor the denominator?
Oh, yeah.
So go for it. So, do I have a volunteer who can factor the numerator, please? All right. So we're gonna go with Ashlyn.
In parentheses, 3x minus 1, and then x plus 2.
Now, please forgive me. I'm gonna double check this really quick. We know that C. Okay, 3 times x is 3x squared. That's good. Negative 1 times 2 is negative 2. That's good. I know 3x times 2 is 6x. I know that negative 1 times x is negative 1x. I add these together, I get 5x, so I know this works. That's our linear term. Okay, excellent. Do I have a volunteer who can tell me how to factor the denominator? Volunteer to factor the denominator. I don't want who doesn't want to volunteer. I just want to know who does want to volunteer. All right, Charlotte?
You were trying to figure out which x was negative or positive, so we think it's negative x plus 3, and then positive x plus 2.
All right. Now, the reason why I wrote it like this is because, well, I don't want to start a mathematical sentence with a negative, because it's unsightly, it's ugly, right? Bad math grammar. And negative x times positive x is negative x squared, so that works, that's good. 3 times 2 is 6, that's good as well. And I know that 3x minus 2x, well, that's positive 1x, so that works well. So do we have any terms that are the same?
Yes.
Yes. Yes, we do. What's the same? What is the same? Abigail?
X plus 2 and 2 plus x.
X plus 2 and 2 plus x. Why can we say that they're the same? Because they don't look the same right now. But why can I say they are the same? Will?
Because addition, it doesn't matter like what side of the addition sign now.
In addition, the order doesn't matter, right? There's the transitive property of addition. So yes, addition is transitive. So, okay, I'm glad somebody got that. All right. So, what is x plus 2 divided by 2 plus x? 1. So that cancels out, okay. And we are left with 3x minus 1 over 3 minus x.
Okay.
There we go. All right.
God, we did it!
Okay, now the loud mouths want to be heard. All right. So, last one. We are going to solve for x. It's not as bad as it looks. Trust me, it's not. This is basically what we just did here. So we have 4kx plus x is equal to 16k squared plus 8k plus 1. All right. So, to solve for x, I would really like there only to be one x. But can I add 4kx with x?
No.
No, I can't.
Absolutely not.
That I agree, because they are not the same term. So you know what I'm going to do?
What?
I can't help but notice that both 4kx and x share a factor. They share a factor of x. So I'm going to factor the x out. So when I factor out the x, I will get x times 4k. That's pretty obvious. What is x divided by x? 1. Maybe if my pen will work. And I start shaking it like it's a king. And now notice how, Ms. Gordon, can you hit the door button, please? Notice how we now only have one x. I know, it's super crazy. All right, so we also need to factor out the left side of the equation. So we have 16k squared plus 8k plus 1. What times what is 16 that adds to 8? 4 and 4. Right,
Two.
right. No, not 2, buddy. Because 2 times 8 is 16, but 2 plus 8 is not.
Oh,
8.
okay.
Alright, so we're going to have 4k plus 1, because 1 times 1 is 1, times 4k plus 1. Okay, that's not too bad. Alright, so normal train track stuff, normal solving linear equations apply. What are we going to do to both sides to get the x all by itself?
Train tracks.
So what are we dividing it by? I heard someone say divide.
4K plus 1.
4k plus 1. What I do to one side, I have to do to the other. Alright, so what's 4k plus 1 divided by 4k plus 1? 1. So we just get x on the left side. And then, oh, we have 1 4kx on the denominator. Well, that's going to cancel out one of the k plus 1s on the right side. And I'm still going to have a 4k plus 1. So x is equal to 4k plus 1.
Yeah!
Yeah, all right. Now, there's one last thing I do need to talk about, and that is restrictions. We know that a fraction cannot have 0 in the denominator. No, we can't. So, looking here, what would make this piece 0? What value of t would make t plus 3 0? Negative 3. So in this case, in this problem up here, t cannot equal negative 3. Because that would make the denominator 0. Which is a no-no. No. Alright, so looking at these binomials, so what would make this binomial here 0? 1. So t cannot equal 1. What about this binomial right here? Negative. And again, these are called restrictions. Only looking at the denominator. What will make this x, or this binomial, turn to 0? Say it, it's on your right.
Great.
What's going to make this binomial 0? Negative 2. And so those, again, are called restrictions.